Section 9.5b is about solving equations by factoring. Again, we learn a new method of factoring, and then we immediately following it up by solving equations using that. Here are our steps to solving equations. I don't expect you to write those down on every slide. At this point, hopefully you have them memorized, but they're up here for reference sake. So over here, we want to set one side of this equation equal to 0. It's already done. Step 2 says to factor. Well, if you notice, this is a p squared, which is a perfect square. You also should know that 9 and 16 are perfect squares. So this is a difference of squares because it has a minus sign in the middle. P squared comes from p and p. 9 over 16 comes from 3/4 and 3/4. One of them has a plus, the other one has a minus. That's factoring a difference of squares, as we've learned. Step 3, set each one of those equal to 0. And then step 4 says solve. So your answers are negative 3/4 and positive 3/4. If you think about it, this will always happen when you have a difference of squares. You're always going to get one answer that's positive and the same answer that's negative because of the plus and minus sign that you create when you factor. Here we want to solve this for x, so we start by getting one side equal to 0. I'll subtract 50x. So 18x cubed minus 50x equals 0. Factor, first thing to look for is a GCF. I notice a 2 and an x will come out, leaving me with a 9x squared minus 25. I like those numbers because they're perfect squares. X squared is a perfect square, and there's a minus. So we know that this binomial will factor as a difference of squares. 3x plus 5 and 3x minus 5. Now something interesting has happened. We've actually created 3 terms, and they all have an x in them. So when we say set each factor equal to 0, we now have to set all 3 of those equal to 0. We've never seen that before. And something that's important here is you're going to end up having 3 solutions. And I want you to notice why. If you go back to the beginning of the problem and you notice this exponent right here, it turns out that whatever your highest exponent is in your polynomial, that's how many solutions you'll have when you factor it at the end. Just something to think about there. So now step 4 says to solve. We'll solve each one of these. X equals 0. So our 3 solutions are 0, negative 5/3, and positive 5/3. This example's one just like the first one we did, so what I would do is I'd pause the video and then I'm going to fast forward all my work and show you what the answer is at the end. Here's the solution to this one. It's a difference of squares. We factor and then we solve. Our final example here is again similar to one we've done in the past, so I'll let you pause the video, try it, and then I'll show you the work. A couple things to point out in this solution here. I moved the 3y over with the 48 because I want to keep the y cubed positive, and then I just flipped it so it looked more like what we were used to. Also, I took out a 3y and then factored the difference of squares, and notice again 3 solutions. My highest exponent was a 3.